In this video, we will solve two problems involving the convergence of infinite series and determining what their sum is if they converge. So the first of these, we have determined if the sum from n equals 4 to infinity of 1 over n times n minus 2 converge, and so evaluate the sum. This is going to fit into our idea of telescoping series. We first need to figure out what that expression looks like in partial fraction form, and that'll help us determine what's going to happen to this sum in the limit. So we can see that for the first example here, 1 over n times n minus 2 should be some a over n plus some b over n minus 2, which means that 1 equals a times n minus 2 plus b times n. If I plug in n equals 0, it'll tell me that 1 is minus 2a, so a is negative 1/2. And normally our sequences don't include 0, but in this case, we're plugging in values here to see what the partial fraction work is. You can plug in anything you want to make that happen. We then plug in n equals 2. We're going to get 1 is 2b, so b is positive 1/2. And so this becomes 1/2 over n minus 2 minus 1/2 over n. So now we can look at the partial sums of this series, which is going to be the sum from n equals 4 up to capital N of now 1/2 over n minus 2 minus 1/2 over n. And we can start writing out the first few terms of this sum. So the series starts at n equals 4. So the first is when I plug 4 into this expression. So when I plug in 4, I will get 1/2 over 4 minus 2, or 2, minus 1/2 over 4. If I plug in 5, I get a 1/2 over 5 minus 2, or 3, minus 1/2 over 5. When I plug in 6, 1/2 over 4, minus 1/2 over 6. If I plug in 7, we'll go one more time to show how this all works out. I get 1/2 over 5 minus 1/2 over 7. If I plug in capital N minus 1, I will get 1/2 over capital N minus 1 minus 2 is capital N minus 3 minus 1/2 over n minus 1. And then plus our last term, which when I plug in capital N, 1/2 over n minus 2 minus 1/2 over n. Now what do we see in terms of cancellation? Well, we see that this 1/2 over 4 will cancel with this plus 1 over here. This minus 5 will cancel with this 1 over here. And the pattern is going to continue where the negative term in this one will cancel out with the positive term 2 steps later. So this 1/2 over 6 will cancel with the 1/2 over 6 showing up in the next term right here. Same with the 1/2 over 7 over here. And now for the end, we see that the terms that get canceled are the ones that are the positive terms because they will appear as a negative version somewhere earlier in the series. So this 1/2 over n minus 3 will show up earlier as the negative term when I'm plugging in n minus 3 into my summation. Right? This is the n minus 1 term. If I were to plug in n minus 3, I would get the negative version of this right here. So this will cancel, as will the n minus 2 for the same reason. When I plug in n minus 2, that is the negative term that I get at that step of the summation. So what I learned from all of this is that I can write s sub n as these first two terms that survive, which is a 1/4 plus 1/6, and then minus these last two terms that don't get canceled out yet, but they would if I added more terms into my series. So minus a 1/2 over n minus 1 minus a 1/2 over n. But now with this, we can see what happens as we take n to infinity. In the limit, we see that both of these terms here go to 0 because they're 1 over n, 1 over n minus 1. They're both going to go to 0 as n goes to infinity, meaning the limit here, which is the entire series, is just 1/4 plus 1/6, or 5/12. Therefore, our result is that this full series converges, and the value is 5/12. This is example 1, our telescoping example. Now example 2 asks about the sum from 2 to infinity of 1/2 3/5 to the n, and that's a geometric series. Write that one down below. And says the ratio here is the part raised to the nth power is 3/5, which is less than 1 absolute value. We know this will converge. The question is then, was it converge to? Well, it converges to, by the formula, c times 1 over 1 minus r, where c is not just the c here, it's the first term of the series. And so in that case, our first term here occurs at n equals 2. So if n equals 2, the term that I get is 1/2 times 3 over 5 squared, which is going to be 9 over 50, because I have a 9 on top and 5 times 5 plus 2 on the bottom. And then my r is again 3/5, so the series here converges to 9 over 50 times 1 over 1 minus 3/5. That's a 2/5 on the bottom, or a 5/2 overall, so 9 over 50 times 5 over 2 is a 9 over 20. And that's how you analyze and evaluate these two infinite series, one that's telescoping, one that is geometric.